Hello and welcome to another session of Morning Tsoding, the show where we code random crap, I guess. So get comfortable and we're gonna start pretty soon. So first thing I need to pour a cup of tea. So today is a Haskell stream, and that means we continue to develop Boids and Haskell. So I just pressed something, I'm not sure what I did. Hope I didn't break anything. So Boids and Haskell is a small project that took way too long for me to do. It's a really simple thing. It's just an algorithm for simulating flocks. It consists of 3 simple rules, and I'm making it already for 14th episode because I'm an idiot, obviously. So yeah, today I'm continuing being an idiot and developing that. So yeah, just pour a cup of tea. So essentially, you just have a bunch of, I would say, agents. I don't know why I want to call them agents, but that's what they are. And they should form flocks, essentially. Yeah, and just fly somewhere. So let's just enter the development environment of our project. We use Nix OS development environments. They are not called development environments. They're just, I don't know, local environments or something. So yeah, in the root of the project, you have default.nix file, and this is just essentially a description of the development environment in Nix programming language. And when I do Nix shell, it just enters that specific development environment, and all of the dependencies are set up. Everything in the path environment variable. Okay, everything is ready for the development. Okay, and then we want to build the project. I'm pretty sure I already built it beforehand, but just in case, I want to double check the shit. And I was about to sip a cup of tea, god damn it, so now I have to continue working. And now we have to execute the executable. And this is how it looks like. So yeah, they kind of form some kind of flocks and fly somewhere, as you can see, and they follow the cursor. Well, I made them follow the cursor because I hoped that it's going to be a little bit more interesting. But the problem with this sort of implementation, I would say, it's buggy, I would say, because they follow the same direction for some reason. I don't know why. Not everybody, but many of them. So there's definitely some bug, and we need to fix that. All right, let me finally sip my tea. And let's take a look at the plan for today's stream. God damn it. I'm really sorry that I sound tired. I don't know why. I did nothing today. Like my entire day was just laying on the couch and doing nothing. And still at the end of the day, I'm fucking tired. Tea is Earl Grey. So today I've planned a really interesting thing. It's called combined rule. So as already discussed many times in previous streams, the entire Boids idea consists of 3 rules. Let me take a look. So here's the page about Boids. I'm not sure if it's an official page, but everybody refers to it as an official page. It's an ultimate source of knowledge about Boids. So there are 3 rules: separation, alignment, and cohesion. As you can read, separation is just steering to avoid crowding local flockmates. Alignment, it's steering towards the average heading of local flockmates, and cohesion is steering to move toward the average position of local flockmates. So these are really simple rules, but they sort of form the entire interesting effect of Boids. And yeah, we coded that in a pretty straightforward way, I would say. Hello, Ninja Trooper, welcome to the stream. How you doing? So let me show how we did that. We apply those rules, unfortunately, separately. I'm sorry, something wrong with my microphone stand. I don't know what exactly. So let me open that shit up. So here they are. So this is the separation rule, alignment rule, and cohesion rule, and they are applied sequentially. And if they apply, they override each other, and that's essentially the problem. Hello, sorry. Hello, Hohavit, or Hohu. I don't know how to pronounce your nickname. I'm really sorry, but I really appreciate you being on my stream. So, and the fact that the rules are applied separately and cancel each other is actually the problem. And this is actually why Boids, our Boids look so fucking boring. Let's admit, they fucking boring, honestly. They could be way more interesting, and I show you in a second if I will be able to fix my fucking microphone stand. If I won't, I will probably just stop the stream. Just kidding, sorry. So, I started this project as some kind of a challenge. If you watch the first episode of Boids and Haskell, you will hear that I say that I want to challenge myself to actually code it without looking up anyone's implementation, just having these 3 rules. And that's the result. I cannot go anywhere from that without somebody's help. So I took a look at the existing implementations of Boids and just learned a couple of things that I did wrong, I would say. Or maybe that could have been done better. So specifically, I was looking at this implementation. This implementation is so fucking awesome. I just love it. This is how Boids should look like, I believe. And I want to get a similar result. Not exactly that result, but something similar. So after reviewing that implementation, by the way, I'm sorry, I didn't give the link to that specific implementation just for people in the chat, because I believe it's really interesting. It's implemented in JavaScript. It's very small. There's nothing much in it. I would say it's probably 100 lines. It's 200 lines, but yeah. So what I've learned by reading that code, the first thing is that our average angle is broken. So we calculate the average angle, the heading to move to, and I do that completely incorrectly. So I left myself a Wikipedia article about how to do that. So you essentially have a bunch of angles. You have to convert them to Cartesian coordinates and just find the mean of them and then convert them back. As I understood, this is how it makes sense. If you just calculate the difference between them, it won't make any sense. Separation rule. Yeah, the most important thing is that you have to apply those rules simultaneously. Not just separately as I do, but simultaneously. Specifically, alignment and cohesion rules are applied by the mean angle of them. So when you apply alignment rule, you get one angle to steer to. When you apply a cohesion rule, you get another angle to steer to. And you just have to take a mean of them and steer to that vector. And this is how it should work, except separation rule. Separation rules should cancel everything and should have highest priority, because this is first thing that the board should do, is to protect its private space, something like that. And interesting thing is that alignment rule has more influence over the cohesion rule, even though they applied simultaneously. Still, the board should steer a little bit more to alignment rule, and I will show how to do that a little bit better. And another thing is just to make it visually look better. I want to wrap position and heading the same way it's done in the implementation in JavaScript. So, well, essentially the position is wrapped. So maybe it's not wrapped. Maybe they die when they go outside the window. Maybe not. Well, let's just observe. So this one probably gonna go to the right, and it should appear on the. God damn it. Okay, yeah, they wrapped vertically. The trace behind Boids is helping seeing what's happening. That's a quite nice feature. So yeah, it's not. Wouldn't say it's the trace. It's just a tail. It's just a static figure, right? It just have tail. Maybe this is something that we should also implement. It's actually yeah. Thanks for pointing that out. Trail. Yeah, I would say it's tail. Tail. But I'm gonna put that at the end of that, like if we will have time. Tail. And Boids with tail. Okay, and the objective for today's stream is to get Boids to the point where they look good, I guess. Hope we will succeed in that. Maybe I have to... yeah, maybe I have to just make them checklists. Boids with tail, so... And also this issue will potentially fix a bunch of bugs and incidents that I didn't have time to actually investigate, or maybe I investigated them but didn't find any good solution, but yeah. Okay, so let's get fucking started. So I'm opening up my... so it looks like I already have my Emacs opened for whatever reason. Oh yeah, I already did that. Is it started inside of the development environment? I don't know. Yeah, it is. Because Emacs works. If I start my Emacs outside of the development environment, I could be able to compile from within the Emacs. So average angle is broken. So let's take a look at that. Average Boids heading. So it's called average Boids heading. And what we do, we just sum up Boids heading and divide it by n, by amount of Boids. So it's completely wrong. We have to do it like in this article, I guess. But this article actually, like this formula is a little bit wrong. You have to divide each of the components by n as well. I think they just forgot to do that. Maybe we'll have to fix that, but later. Let's leave it for later. Stack wrapped JHCI or standard JHCI. I think it uses stack JHCI, but I'm not sure about that. I don't know. I don't even know how to check. So I have a sorry. I have a REPL. So that means we have a external process that is linked with Emacs, and that means we can just list processes. Yeah, it uses stack JHCI. It's pretty good. It recognizes that you have stack and uses that. I remember that it worked even without stack. Maybe it just checks the environment, like it has like different states when you have stack, when you don't have. Yeah, it's pretty good. So, I mean, it's the integration with Emacs in Haskell is pretty mature. I'm pretty sure that many Haskellers are like use Emacs and try to maintain that integration. All right. So another thing that I want to do, I want to get rid of that error. I don't. Yeah, this is something that I don't like about the design of standard library of Haskell. For example, you have function head, right? It takes a list and returns just the element of the list. But what will happen if you provide an empty list? It doesn't have any elements, so you will get an exception. Why don't we have a head that returns maybe A? And I don't know why it was implemented like that, but for me it seems like a design flaw of the library, or maybe it was a trick to lower the how say that? So to to make Haskell easier for newcomers. That's what I was trying to say. Yeah, I know about that. Like, I mean, why bother? That's not the point I was trying to make. I wasn't just saying that I don't know that there's something solved or there's already a solution. The point is we have a standard library, we have a flow design of a flow standard library. Yes, there are solutions, they are separate packages. I know that. That's not the point. Why do I bother, seriously? So, and I did the same mistake. I did the same mistake, and I want to fix that. I'm gonna just do maybe float. And I'm probably gonna do the same Boid position. So let's trace. Yeah, I'm gonna have to do. Yeah, that's true. What I wanted to say, more type safe average functions. So just to just to not forget where I'm going, where am I going with all that. So in case of empty list, we're gonna just return nothing. In case of something, we're gonna return something. It's kind of funny. Why did they call it just? If the like negative result is nothing, why won't you call it something? I mean, yeah. Like in Scala, it's called sum, but yeah, it's pretty close. Just so many names. Why do we have to remember so many names? Yeah, I guess that's right. So let's take a look at the compilation errors. I wonder how you jump to a compilation error. So do they use fly check, because fly check has a standard key bindings for that, but I'm not sure. Let's go jump. Okay, so Haskell jump. Let's say Haskell mod jump to error. Haskell. Maybe I can even look it up in the code of Haskell mode, but I don't know. Jump to error. Maybe there's something. Okay, there is a tutorial. Tutorial error. Jump to error. Oh, fucking hell! God damn it! Where is this table? Okay. Navigate errors in the file. Oh, maybe it's the same as in the compilation mode. Let me see. No, it is not. Okay, so I can see the error, but I want to quickly jump there. Or I can just fucking... Okay. I have a deja vu, I think. I had the same conversation, and I found the solution and just forgot about it. Okay. This is kind of funny. Okay. So you guide Boid to angle, but target heading can be 0. It's kind of funny. We check like when the Boids are empty, right? And we throw an error on empty near Boids. So we check. So the check that should have been done inside of this function is done outside of this function. So I'm pretty sure we can just get rid of that. So I'm getting target. I don't know how to properly do that. It's really inconvenient because it's a huge expression. I just don't want to lose it. I just want to use it as a reference, but it's really difficult to get out of the way. So len Boid, what do we do? We need to apply a function, but the target heading is the second argument. So we have to do a really stupid thing. Guide Boid to angle h Boid. I'm pretty sure this is the operator for working with the maybes, not only maybes, but with the functors in general, to target heading, right? And then I do something like from maybe and use Boid as the default value. And this is a terrible code, seriously. Maybe I just have to use the do notation. So essentially, I use target heading and put that thing here, right? Then I guide Boid to, okay, so I have to call guided Boid, probably using some kind of let shit. Oh, maybe not, maybe I just can return that. Guide Boid to angle, target heading Boid, and I still need to invoke from maybe somewhere. So anyway, probably to do that properly, right, I have to introduce some kind of guided Boid, right? Wait a second, why do we use other Boids and the near Boids are not used? This is strange. Is that my typo that I introduced recently? Or is that the typo that was always there? Oh my fucking goodness. Let me take a look. So, I can see that. Case of near Boids. Then target. Oh my god, I just found a bug in my shitty implementation. I mean, the implementation was already shitty, and I found a bug in it. Another bug that I didn't know about. Oh my god, let me discard the changes. I'm gonna show you. This is so fucking interesting. So, I get nearby Boids, right? But I calculate average position by all of the Boids. That's fucking why they follow the same direction. Because I calculate average heading of all of the Boids instead of near Boids. So there should be near Boids here. So near Boids is not used anywhere. Is there any warning about not used variables? I mean, it's fucking used. It won't help. You have a safest language in the world, and still it cannot protect you from that. I mean, the compiler won't say anything even if I turn on like somehow the warnings about not used variables, because this variable is fucking used. Oh my fucking goodness, this is terrible. I mean, it's not terrible like from a Haskell perspective, but from software development environment, like point of view. Like, you can shoot your leg by anything. It doesn't matter how safe it is. If you're like stupid as me, you will shoot your leg. Like the language won't help me. I'm just so, I don't know. I mean, yeah. So I just need to use new Boids. Wait a second. Oh yeah. There was other Boids. And god damn it. I just completely. I'm just completely lost. I'm very sorry. Yeah, here it is. Maybe not. Yes, this one. This should be near Boids. The file is too huge. I'm really sorry. So I just need to navigate it a little bit better. So I want to get all the Boids back, right, and just see how it works right now. Okay, they follow the mouse, but it doesn't fucking matter. Now, if I replace other Boids, not here, with near Boids, it will fix the problem. Now, will it? Does it fix the problem? I don't think it fixes the problem. I didn't compile it. Okay, so I also forgot to compile that. Okay. It doesn't compile because why? Yeah, target. Yeah, because I already did the change, like more type-safe version of a function. So I need to stash it somehow. Can I stash a hunk? I would really like to stage a hunk, but looks like I cannot. So I'm gonna stage the everything. I need to revert everything back and, yeah, replace that near Boids again. Fucking hell, seriously. Oh, it compiles. Come on, you can do that. Now they finally don't follow the same direction. I found a bug. Yes. This is so fucking great. Okay, I have an issue for that. For following the same direction. Maybe we just plan that for today's stream and fix that specific issue here. Because it's fucking great that I found this bug. Okay, so just tap on it in the repo buffer. Okay. Fix the bug with following the same direction. So what do we need to do? Plan bug on stream. Plan bug on stream. Remove ref from combined rule issue. This is something that I just want to do and do not want to forget about. Following the same direction, which one is that? All boards of the seem to follow the same direction. Okay, this one, 54. So this specific issue doesn't fix 54. It's a separate issue. Is not related to how rules are applied. So I'm going to also plan today. It's a really interesting discovery. I was preparing to the stream yesterday and I didn't found that. Maybe this is because I didn't try to look at my old code and try to fix that or something. I'm programming in the safest language in the world and still shoot my leg. It's just incredible in my opinion. Plan back on the stream and let's say that it's in progress. We're gonna work on that specifically first. So let me just quickly fix that. Use Boids HS. So here's the change. It's a really quick change. I also wonder if I use near Boids appropriately and everywhere else. And the point is, I think I do. Okay, in separate Boids rule, I have near Boids. Yeah, here they are. And yeah, use near Boids. In line Boid, I just fixed that. And in stick Boid, I just fixed, I use the correct one. Okay. I need to create a branch. 54 Boids follow same direction. There we go. Fix align rule 54. the align rule was applied to all of the boids by mistake. It's really interesting. So the mistake was exactly what the bug is. The mistake was exactly what the bug was. We had a bug that all boids follow the same direction. This is because the align rule was applied to everything. That's exactly what it was. It's so fascinating, in my opinion. So let me push that branch, and we're gonna do make a pull request. Hopefully, I really hope we're gonna make a pull request. Fix align rule, and that rule fixes. They finally started to put the body of the commit message to the body of the pull request. I think they didn't do that before. They recently started to do that. I'm gonna send to myself, don't know why, I'm just gonna say that it's a bug. And yep. Okay, so let's just create a pull request, and we probably will have to wait until the continuous integration is done. In the meantime, we're gonna start another project. Issue. I'm sorry, confused. Well, someone setting off the fireworks again. Somebody celebrating something again. I don't know what exactly. People always celebrate something in Russia. Like Russia has, like, I heard Russia has the most holidays in the world. So there's many holidays in Russia. So like basically Russians don't like to work, and yeah, they like to celebrate shit and get drunk. I mean, we have 10 days holiday after the New Year. Oh, you have the same thing about India. Maybe they say that in every country. So, like for everybody, like our country has the most holidays. Yeah. I mean, like specifically about India, as like as far as I know about India, it's so multicultural. There's so many cultures. There's so many ethnicities there. So it's no surprise that there are many holidays there. Maybe I'm wrong, but it's just my guess. Maybe like each individual state has its own like holidays, and if you sum up all of the holidays, it's just a big number. But I don't know. Yeah, okay, cool. I'm glad I'm right. So, we fixed the bug. This is great. We fixed the bug that they didn't even hope to fix, like, intentionally. Because I had that bug for a long time. I didn't understand what was the cause, and I was hoping that like rewriting, like using completely different concept will like fix it by an accident, and I wasn't hoping to understand what was causing that bug, but we did that. I'm really glad. So since the merge request is not merged yet, I'm gonna start a new branch, like on top of the current branch, and then I'll rebase everything. And oh my gosh, force push. I'm gonna be 64 combined rule. Yeah, they probably say celebrate fixing the bug. Yeah. So another thing that I want to do, like the first thing that I want to do is to implement wrapping the position. I'm not sure if I need to wrap the heading though. It's not really that interesting. But wrapping position is pretty interesting. Let me just say that. Yeah, I don't know why I wrote that. Excuse me. So how are we going to do that? We have some kind of, we have a size of the world. It's not a size of the world, though. It's just the size of the square within which we generate the Boids. The Boid starts like within the square. Random Boid. So this is the, I would say, size of the square. I want to move that magic constant to a separate constant. Let's call that thing a world size. World size is gonna be 1,200. 1,200. I think this is how people say that. So, and yeah, let's just replace that with world size. There we go. Actually, I wonder, do I have to do something like that? I'm not sure. Maybe I do not. Okay. Now I can also check how it works. By the way, I just realized that I can run the same command from within Emacs, so I don't have to bother my terminal. So let's just file compile. Yay, it's much more convenient. Okay. Oh, I'm so glad they look better. They all look better. They don't try to separate though for some reason. Okay, so now I need to find, yeah, here this next Boid. And here we have to wrap the world. Maybe I have to implement a function, wrap world. By the way, is the merge request, pull request, I'm sorry. I've been using GitLab a lot recently. And yeah, I start to use the terminology of GitLab. They call pull request merge requests. So I'm doing right now more type safe average function. This is not what I want to do right now. I want to implement world wrap. So I'm working on world wrap right now. Yeah, we continue. This is exactly why I started to do that to-do org thing, because as you can see, I get distracted so fucking easily that I forget this shit. And yeah, it's here. So I'm gonna do that. But first I want to implement world wrap and see how Boids behave in a wrapped world. And then I'll make more type safe. Yeah, thanks for pointing that out. But the problem is with, like, sometimes I'm so out of focus that I forget to keep updating that file. Nothing helps. I'm hopeless. Wrap, maybe just go wrap point, something like that is gonna get, let's call it world wrap. So just say that the intent, it sort of looks up the global variable world size or something. So it's gonna get a point and return a point. That's fucking point. Yeah, that's pretty much it. So since the size, yeah, to-do org is really nice. So it helps me a lot. And yeah, since I started to implement world wrap point, I'm not sure if I have to just update that file, world wrap point function. Maybe I have to function apply world wrap point in next Boid. It's too fine-grained, but yeah, let's just roll with it. So what I wanted to do. So the beginning of the world's coordinate is at the center, as far as I know. By world size, what do I mean by world size? I don't remember. So world size is just a half of a side of a square for some reason. Maybe it shouldn't be, but yeah, this is the world size. And yeah, it's pretty much the same as the vertical one, and yeah, something like that. I don't know why I did that. Maybe just to make it easier to randomly generate Boids, because I don't have to do any arithmetical operations when I just generate where it is. So yeah, so when I generate a random position, it's just from minus world to world. Okay, let's just roll with it, whatever. And when I want to wrap that, I have to add world size, right? I said world size, goddammit. So yeah, when I have a point, I just sort of shift the entire square to the 0. So the entire world square becomes something like that, along with the point. Right, point moves somewhere here. Then I have to apply mod, essentially wrap it, and then I have to move the square back to its original position. Right. So I do plus world, then I need to do mod. I remember that there's a mod function in Haskell, something like if 3 and base, let's go with something like 4 and base 3 should be 1, right? And don't remember if it works correctly with negative numbers. Like many programming languages have problem with negative numbers in mod. Let's just check that. It doesn't have any problems. Yeah. By the way, do you know the problem with the negative numbers? I really feel like I want to explain that problem. Because sometimes like languages calculate the reminder instead of modular. Modular arithmetic is really interesting. So in a sense, I don't remember if I already explained that in the stream, but I feel like I want to do that again, just in case. Like talk about modular arithmetic, because it really fascinates me, and there's some little information about modular arithmetic on internet, and at least in my school they didn't teach us that much, even in the university. And yeah, most of the information about modular arithmetic I just learned myself for some reason, even though I graduated from university as a computer fucking scientist. So so we have like numbers, integer, positive integer numbers. And if we're talking about modular arithmetic in base 3, I'm not sure if it's called base, but I like to call it base. The same sequence is got translated to the following sequence from 0, 1, 2, and then it repeats itself. 0, 1, 2, 0, 1, and to the infinity. So that's modular arithmetic. When you, for example, sum up 2 plus 3 in modular 3 by base 3, so you will get 5 in regular arithmetic, but in modular in base 3 you will get 2, because 5 equivalent to 2. And what is interesting is that it applies the same to the negative numbers. So if we continue the sequence to the left, let me just see how I can easily do that. So I can do something like that, and do a negative number here, minus 2, minus 3, no, minus 3, and so on. So it should be the same, but opposite direction. It should be 2, 1, 0, and so on. It goes like back. And yeah, sometimes in some languages, when you do A mod B, right, and A is negative, what you actually get is the result of a positive A mod B, and just apply it minus. And yeah, it's more of a reminder, and it doesn't work correctly in terms of modular arithmetic. I don't know if it what I explained makes sense, but I just wanted to explain that. And yeah, so as you can see, if we'll try to do minus 3, maybe even -2 by base 3, something like that, in Haskell, it works perfectly fine, and we get 1 as exactly as we expected, like on this. So yeah, that's pretty much it. But we need to work with real numbers as well. And for real numbers, as far as I know, there is mod prime. So mod without prime works with only integral numbers, and you cannot do stuff like this, or you can. I don't think so. It didn't calculate that. So if we do something like show, right, probably wrong syntax or something. Yeah, it doesn't work like that. But if we do mod prime instead, it works perfectly. It doesn't work perfectly with numbers. This is because it's in some separate module. Asking Google. I even remember the name of the module. It's fixed. I don't know why it's called like that. Let's take a look. The module defines a fixed type for fixed precision arithmetic. Okay, this is great. The parameter to fixed is... okay, I'm not interested anymore. So what I need to do is to just bring up the data fixed module to the REPL, right? And probably import it in the Boids module as well. Okay, like that. And the module prime will be available for me, hopefully. Yeah, now it works, and we can do something like this. Yep, totally works, even with the like real numbers. So we have to use, and we are using floating point like arithmetic, so we need that thing. Yeah, I add world size, then what do? I do module prime twice of world size, because the size of the side of the square is double size of the world by definition. And then we add world size back. So by adding world size first, we just move it to the right. Then we apply modular arithmetic. Then like modular arithmetic by base twice as world size, and then we add world size. I'm not sure if it makes any sense, but whatever. I'm not sure if I want to use the infix operation, because I'm not sure about the priority of the operation, so it's easier for me to do something like that. In this case, I'm more sure about the arithmetic. Okay. Next, I'm gonna do the same, but for y. And yeah, we just implemented world wrap function. We can go just world wrap point here, and it compiles. It's pretty great. Yeah, where is my tea? Doesn't fucking work. I wonder what happened. I did, like, oh my god. Something went terribly wrong. Let me see. So I saw them, but then, like, don't understand. Now I don't see them. Where they are? Seriously. Oh. Minus. So yeah, I just moved it to the right, but instead of moving to the left, I moved to the right again. So stupid of me, I'm really sorry. Okay, this is better. Now they are wrapped in the world. They're not that so bad, though. I really like that they're not sticking to the same direction anymore. This is such a terrible... this was a terrible bug. We can take a look at them. They also follow the cursor. At least they try to. Okay. Nice. Where is my to-do? I did that. Implement involved wrap, but I also have to commit and push. I can't forget about that because I want to check my pull request. Is the pull request done? Fix align rule. Okay, great. It's done. I just clicked merge, but for some reason the page just refreshed. I'm gonna click it again and delete the branch. Okay, so it closed this issue. Let's take a look at the issue itself. It didn't refer to any other issues. Everything is great. Now, probably need to rebase. But first I need to commit and push though. So that essentially means that rebase has to be done here. World wrap Boids position 64, and let's just push that. I'm not sure if I want to push that. We didn't create that branch remotely yet. Okay, I'm gonna fetch the latest shit from all of the remotes. Okay, we just fetched everything. I can change to the master. Academic. Merge the master and remove Boids for the same direction branch. Let's go back. Okay, so this is where our branch is, and this is where the master. So essentially what we need to do is to rebase onto the master, and it worked pretty well. So now I can push that without even force pushing, because we didn't create the branch in the first place, so I don't have to force push anything. Which is great, now we done on that. Now I need to get back to more type safe average function. So we're working with Boids heading. Luckily I saved my progress on that in the stash, so I can just apply it, but there is a merge conflict. It contains a fix that is already applied to the branch. So I don't know, can I discard a hunk from... Okay, so this is really interesting. Once I apply this stash, I'm gonna get a merge conflict, so I will have to probably resolve it somehow. So let's just give it a try. Oh, this is interesting. It didn't apply. It didn't create the merge conflict. So is Git that smart? Wow, that's pretty impressive. Like, I heard that like merge, I don't know, algorithm in Git is pretty smart, but I didn't know that it's that smart. Anyway, so now the code is incompilable, probably. And let's just jump to the error. Yeah, I was trying to get some kind of guided void, which is essentially takes a target heading and average, and then it returns guide void to angle target heading void. So once you have a guided void, you don't need target heading and you don't need all of that. So and then you just apply from maybe the default value of maybe is void, but if guided void contains something, it will return that. Okay. This is interesting. Something went wrong, and I don't exactly know what. Probably have to wrap it in parentheses. Now it works. It works pretty. It's pretty good. Let's try to compile that and run and see if we didn't break anything. Yeah, because breaking anything is the last thing I want to do. And as we saw, even using Haskell doesn't save you from breaking anything. Like, you can break anything even in Haskell, and no warnings can save you. So pretty good. I really like how it looks like. See that? Just little boids, just little swarms of boids. But they're kind of boring, honestly. They're kind of boring. They don't even separate much. Let me just increase the separation distance, maybe 20. How about that? So I want them to separate more. Okay, damn it. Okay. I like how they attract to the cursor. And they also merge. Really interesting. Okay. Moving on. So probably won't take that change that I made recently, so I'm gonna discard that. Okay. I need to save the name of the function just to use it in the commit message. Make more type safe. That's right. 64. It's more type safe now. It's more type safe now. And now we have to do the same with this function. Okay. Just did I have to revert buffer? Okay, maybe point. If it's empty list, we have to return nothing. If it's not empty list, we have to return just that thing. It's already broken somewhere, but I don't see where. I cannot jump there for some reason. Maybe point. Okay, the same shit. So let's just call that a separated void. Why not? Do average void position. Average position and average void position. And then we have to do something like escape direction. Escape direction is just this, and once we have that, we can return an escaped void like that. And then from maybe return either void or separated void. Okay, something average voids pause. This is because I have to use average position instead of that. Average position. Here we go. It doesn't fucking compile yet. Why? Oh, and also have to average void pause. So we use the same function in separation. I don't. Why do we use? Oh, I know why. All right, makes sense. Oh, I have to use the same logic here as well. Stick the void to average position, average so fucking boring. Let target let's just call a target point then. And once we have target point, we can use that function here and just use the same. So it's a really copy-paste code. It feels like copy-paste, even though we didn't intentionally copy-paste it. And it compiles, great. So let's check if we didn't break anything. Like, it's really interesting. I'm doing such an intense work, but since it's a refactoring, the result isn't like it doesn't have any visible results. So what I was doing again, I'm probably paying off the technical debt. Kind of like them. Kind of like how they feel, how they look. Okay. They're so calm. Like if we compare them to the implementation in JavaScript, they're always like wiggling. Maybe not. Also, okay, I don't know. Maybe they have to be faster. We can make them faster though. We can make them steer faster. And we can make them move faster. Okay. Yeah, faster. Okay. Ooh, this is more interesting. Just a little bit. They became a little bit more active, I would say. Maybe not. Like, let's make them even more faster. Yeah, that is interesting. I like how they merge these, so maybe we don't even need a combined rule. It's already good, like it's... I don't know. I like the result, honestly. Okay, so I just tweaked a couple of parameters. I want to separate this change. So this hung, we're gonna say tweak the simulation parameters 64, and this change is going to be making the average Boid pose more type safe. Okay, so I'm gonna stage that. It's not staged yet. Make more type safe 64. Let's just push that to the repo. Okay, what's next to do? We made everything type safe, so I'm running out of ideas. Okay, I wrap that. Average angle is broken. Okay, this one is interesting. So I'm going to put that here. Average angle is broken and it has to be completely different. Probably don't want to close that. Just want to open that and separate a tab. I don't need that tab anymore. Probably need that. No, it's a duplicate of already existing tab. I don't need that tab anymore. Maybe I need this one for quick Google searches. Okay, so we can apply this formula. Let's just fucking do that. Okay, average Boids heading. I'm not sure if it's unit tested though. Let me just quickly find. It's not unit tested. Great, so we don't have to fix unit tests. So depressing. So what do we have to do? We have to extract the headings. Okay, so headings, which is map Boid heading Boids. Right. Once we have the headings, what do we do? I just map the headings with sin, and another one is with sign. I'm sorry, sign, because all of my headings are mapped with sin. This is just marvelous. What next? Then I have to divide all of that by n. I'm pretty sure I have to do that by n, and then use a10 to function to convert it back to, you know, to radius or something. And then I have to play just. So, yeah, I think that fixes that. Heading s. Here we go. It still doesn't fucking compile. I wonder why. Just is not applied properly. I wonder why. So what does it say once again? Error. Oh, this is because I have to sum it up. Fuck yeah. What is that font? It's Ubuntu Mono. So if you're using Ubuntu, it's probably already there. But like for Nixos, I installed it separately. Ubuntu Mono. Yeah. I don't know what to write here. Weight, regular, style, normal, italic. Yeah. Anyway, this one. Okay, so I fixed everything, so let's just give it a try and see if it fixed, like if it improved the behavior. I don't know. So I just realized that I was calculating the angle incorrectly, and I hoped if it fixes anything. Does it fix anything, honestly? Look, it feels like they act the same. Let me just stash that and try again. God damn it. Honestly, I don't see any significant difference. But anyway, we have to calculate the average heading like correctly. So I'm gonna commit that anyway. Average angle is broken. Yeah. Average angle correctly. Probably gonna provide the link to the Wikipedia article. Let's just push that. Where is my to-do? What else do we have? So now we have to come up with the combined rule. Let's just do that. So the point of combined rule is applying alignment rule and cohesion rule simultaneously. But I don't know, at this point I'm not sure if it's really needed, because once we fix that bug when the like boids follow the same direction, they look good, I guess. So I'm not sure if it's even needed. So what I wanted to do, I wanted to lower the separation distance, because it feels like they are too close. I want to just play with the parameters a little bit. Yeah, that's weird. It's really interesting. So but if I can follow the same direction again, do they? They not. They can still steer them to the wrong direction. Sometimes, yeah. Yeah. Okay. It's kind of interesting. So I just realized the separation distance works a little bit differently. So that means it has to be bigger to make any effect. I'm sorry that I'm playing with the parameters, but it feels like separation distance is not even applied anymore. So let me just make it bigger. I'm gonna check one last thing and we'll continue like implementing the combine rule. They behave so interesting. Okay, I'm sorry. So about the combined rule, where all of our rules? Where's my Watcom? So we have separation rule, alignment rule, and cohesion rule, and all of the rules are just functions that map current boids to other boids, to the next state of the boids. So we need to create another function, another rule, which is going to be called combined rule. It applies several rules simultaneously. Boid, and we will use a function, boids product. It just traverses all of the boids one-to-many in one-to-many fashion or something. I don't know. So we need a function. How to call that? I don't know how to call that. It's like in case of alignment rule, we have a function align boid. In case of cohesion rule, we have a function stick boid. In case of combine rule, what do we have? Combine boid. It's so stupid. Combine. I'm sorry. Combine. But it doesn't combine any boids. It's just, I don't know. It just applies several rules. Let's just call it adjust boid. Adjust boid. Whatever. An adjust boid function takes a boid and other boids and returns a new state of the boid. Undefined. Okay, it doesn't compile. Boids product. Because it should return several boids. Okay, now it compiles. So how combined rule is going to be used? It's going to replace this three function. Combined rule. What? Sorry, what? Combined rule. I said. Okay. Great. Everything compiles. So we are implement combined rule function. So the function is adjust Boid. So the point of this entire combined rule is that the Boid can be in two states. It can be maybe even 3 states. So let's say in 3 states. In the neutral state, where nothing affects it and it just like flies forward because there are no like nearby Boids that can affect its behavior. Another state is shine away state, when the Boid too close to some other Boid and it tries to separate. So basically separation rule. And the third state is going to be interested Boid. It's a Boid that is interested in a specific point in the space and just move there. 3 states of the Boid. We take that Boid that we need to modify other Boids, and we just need to produce a new Boid. What is interesting is that we have shied away Boid, which can be missing because there's nothing to shy away from. And we can have interested Boid also, that can be missing because there may be nothing to be interested in. Alright, so they all are maybes, right? In Haskell we have an interesting operator for all of them. This one. It just takes the one that is available. So essentially, it takes a look at the first argument, and if it's not nothing, it takes that argument. If it's nothing, it takes the second argument. That's the entire point of that operator. So I can do something like just 5, just 6, and it takes... Yeah, I probably have to import something for it to make work. I don't know what specifically, but god damn it. Control applicative. Okay, so I need to import control applicative. We also have to add that import to the main file. Import that. Okay, then if I do that, I will get just 5, right? Just 6 was ignored, but if it's nothing, I will get just 6. And if both of them are nothing, I get nothing. So I'm gonna use the same idea. First, we're gonna take either shied away Boid, because separation rule has the highest priority. Boids always try to separate, no matter what. Or we get interested Boid, if we have one. So yeah, something like that. And sometimes both of them can be nothing, so that means we have to use the default value, which is just the initial state of the Boid. From maybe Boid, something like that, and it should compile. Yeah, great, it compiles. And we can even slightly adjust all of that. Yeah, it works perfectly. It compiles, but it won't work because we have undefined shit. But yeah, it still compiles. And this is something I really like about Haskell, is that I can develop it like top down. Because first I define things like shied away Boid and interested Boid, and then I'll just need to specify them later, and I can check that everything compiles. So yeah, I can continue developing. Even though in the runtime the program won't work, but at least it compiles. Okay, I want to make a little break. because I need to refill my teapot of tea. And once I have refilled my tea, we're going to continue doing some incomprehensible Haskell programming. Alright, let's make a little break. Have fun. Alright, I'm back. So let's continue, I guess. What I was doing. What am I doing with my life? Okay, so we need to implement this shit. Yeah, I made myself a cup of tea. 2 cups of tea. Actually, the entire teapot of tea. I'm not sure if it's ready yet. Maybe it's ready. So, shied away Boid and interested Boid. I think I'm gonna start probably with interested Boid. So for interested Boid, we have to calculate the alignment, the average alignment of the group, and the average position of the group, and we have to find the mean between the average between those things. Pretty much. For shied away Boid, we have to find the closest Boid to the current one, and if it's too close, if it exceeds the separation distance, we have to shy away from it. We just have to turn to other direction. It's something like that. And that's pretty much it. So, and once we've done that, we created the adjust rule, the combined rule, and everything's gonna be great. I think the tea is not ready yet, so I probably have to wait. I don't want to wait. I want my tea now. Oh well. Probably have to drink vodka instead. I just realized how thirsty I am. Okay. So interested Boid. Let's assume that we have alignment heading, which can be probably missing. That's interesting. So, yeah, we use different distances for alignment and cohesion, and that essentially means that some headings can be missing, and yeah, we have to deal with all that. Okay, so we're gonna use maybe void for alignment. No, maybe float for alignment, and cohesion heading. So both of them is gonna be headings. Cohesion heading. Okay, so we have 2 headings, and interested Boid should just use that. Okay, this is interesting. So let's assume that we have both of the alignment headings, right? How do we apply a function to them? So essentially we just have to calculate the mean between them. Just imagine that you have 2 maybes, right? How do you apply a function to them? Well, there is interesting function. I don't remember its name, but essentially you can even Google it up. You take one maybe, right? You take another maybe with the same type. Yeah, we're talking about the same type. Then the third argument, you take a function with 2 arguments, and return maybe again maybe, yeah, lift a2. This is essentially what it does, but it takes the function first. Yeah, it's lift applicative. How can we even check that? So we use lift a2. It takes function first, so essentially we can put plus there, and just 5, just 6, and we'll sum it up and wrap with maybe again. Yeah, this is how you sum up the numbers inside of a maybe monad. So we're using lift a2, and we're going to use the same thing for these things as well, because alignment heading, cohesion heading are maybes because they can be missing. So yeah, I'm going to do lift a2. Heading 1, heading 2. I'm just going to call them like cohesion and alignment, just for simplicity, and the one is going to be cohesion heading and alignment heading. Um, yeah. What is interesting, if one of them is nothing, the entire result is going to be nothing, so we also have to keep that in mind. Nothing. Nothing. Something German. I'm sorry. I don't know German, so I cannot say if it's German or not. So, if one of them is nothing, the entire expression is nothing, so we have to keep that in mind. But to work around that, we can use the same strange operator. I don't know the names of those operators. So yeah. If that thing is nothing, that we use just a cohesion heading. If this is nothing and cohesion heading is nothing as well, then we use the alignment heading. Maybe, I don't know, maybe alignment heading should have a high priority. What do you think? I think yes. Okay, this is how we do that. And now we have alignment and cohesion unwrapped here, and we just need to calculate the average heading of them. What is interesting is that we already have average Boid heading, but we need to do that shit for the actual numbers of the heading. So we need to separate the functionality of average Boid heading into a separate function. So we have to probably do average heading. So yeah. What is my to do? So I'm working on implementing combine rule. What do I need to do right now? Let me see. I'm working on an interested Boid, I think. And I'm also working on interested Boid. Okay, so I'm working on interested Boid and on alignment heading and cohesion heading. Oh my god, okay. So I need to separate average heading from average Boid heading. Something like that. This is what I'm working on right now. Probably. Average Boid heading. Boids heading. Where is that function? Here it is. So, I just need average heading. Maybe I can even copy paste that, because that will be much more easier. Average heading, and instead of Boids, it's gonna take a bunch of floats. I'm gonna call it headings, and we don't need to extract them anymore. That's right. And once we have that, we can re-implement the average Boids heading in terms of average headings. So what do? We do something like that. Average heading length headings. Okay, it doesn't compile for some reason. I wonder why. So what does it say? Couldn't match float with void. Yeah, that is kind of true. I know why. Okay. We need to calculate average Boids heading between C and A. And what is interesting is that this shit also returns maybe. So it's gonna be difficult. And I probably need to so I probably need to extract yeah, I already did that. Extract this entire heading to something different. Let's call that interesting direction. It's gonna be maybe float. It will combine alignment and cohesion. Okay, both of them. Undefined yet. Okay, great. An interested Boid is gonna use that somehow. So interesting direction, right? Interesting direction. And we just need to flat map it somehow again, I guess. Or maybe not. Direction. And we just return what? We take the current void and we modify its the void heading with direction. Or maybe I'm gonna call it heading. This is how it's gonna be. So interested void. Now we have to fill that in. Lift A is going to use the average void heading CA, but this entire expression is not float, is also how to say that, it's maybe float, so it's not going to compile because we have type maybe float, and we have to flat map it some, like in a sense. To do that, I need to do the following interesting thing. I need to flat map it with ID. So something wrong. Couldn't match float with void. Oh yeah, because I had to use average heading instead of that. Yes, perfect. Does this code makes any sense? Like, I don't know. Know if it does, but it feels like way more complicated than it should be. Okay, alignment heading. So we have to get the near voids. Right. How do we get the nearby voids? But we have to get the nearby voids according to the alignments. Distance, I don't fucking know. Interested by it. So alignment heading. And then I will have to do shade away point. Shade away point. It's too much of a work. I think my tea is ready. Let me just pour a cup of it. I don't know why I feel so tired. So, cohesion heading, maybe alignment heading. Well, let's start with alignment heading. I think it's a little bit easier. So we need to get the near voids, get nearby voids. We use void, alignment distance, and other voids. Okay, we've got nearby voids. Now we have to calculate the average voids heading. Right, so we calculate the average voids heading. That's pretty much it. But get nearby voids, I think it returns maybe. Oh yeah, this one is interesting. Yeah, average voids heading can return maybe. Oh yeah, so it compiles. So this is gonna be almost the same for average, for cohesion heading as well. I didn't expect that it's gonna be so fast, so quick implementation. Okay, so we have to get nearby voids, void cohesion distance this time, the voids. Then we have to calculate the average voids position. What is interesting is that it's not going to compile because we expect a heading here, an angle essentially. So we have to convert. It's going to be really fucking interesting. So we have to calculate. Yeah, we have to apply a function there. So essentially, we're gonna take a function, swarm pause, right? Defined. I'm gonna apply it to that motherfucker. Does it compile? Yes, it does. Okay, we have swarm position, and we need to build a vector from the Boid position of the current Boid and swarm position. Right. Once we have that, we have to take an angle of that vector, and this is how it's going to work, or maybe not. So what exactly wrong? Oh no, let's go swarm. Swarm. Yeah, that's right. Maybe we have to do something stupid like that. Yes, we had to do something stupid like that. Yes, this is the terrible code. Can you even read that? Oh my god. Why did they write that? This is so terrible. Okay, where's my team? It's just completely unreadable. I love it. So we need to calculate. So we finally calculated the interested Boid based on like cohesion and alignment rules. Yeah. Where is my to-do? Cohesion heading. And now we have to calculate the shied away Boid. For shied away Boid, we probably need a function to close Boid. Not the function, but yeah, everything is a function in Haskell. Boid. It may be missing. Everything can be missing in this case, I guess. To close point Boid. And also we need a function shy away. It's pretty interesting function. Essentially, it takes a Boid, another Boid, and returns a Boid. So it takes a shy Boid as the first argument, then it takes a scary Boid as the second argument, and it will return the modified shy Boid depending on the position of the scary Boid. So what do we do? We need to modify the shy Boid and modify its heading. It's gonna be equal to heading, and heading is gonna be essentially, what the fuck did I do? This from points. It's gonna come from the scary Boid position, scary Boid position, shy Boid. Okay, it can be like that. Okay, it even compiles. Now we have a shy away function, which is pretty useful. So we're gonna use that for to close. So I'm gonna use Boid apply to close Boid. So we're gonna shy away from to close Boid if it exists. If it does not exist, yeah, the shied away Boid is not gonna exist as well. So now we have to find the closest point to the current Boid. Probably according to the separation distance. So probably need to do something like get nearby Boid separation distance. Other Boids. And what is interesting is that it returns list. What we want to do, like, we can take any arbitrary Boid from the nearby Boids and just use it to shy away from. How about that? So we need a function that takes a list of shit and returns a maybe of the first element of shit. I remember that there was such function. Yeah, it's called list to maybe. We're gonna use it. List to maybe. Yes. And yep, it works. So We finally implemented combined rule. This is how it looks like. This is the full combined rule that applies all of the three rules simultaneously. I don't know if it's gonna work, but it compiles, it type checks. So all of the types match together. So, I don't know. Maybe it will work, maybe it will not. So let's just execute that and see if it works. I'm not sure if it's gonna look good or whatever. What the fuck is going on with What the fuck? Oh my gosh. Why do they behave like that? Oh my god, this is terrible. I probably know why. We have to tweak those things somehow. What is going on outside? I don't fucking know anymore. This is fucking terrible. Why do they fucking do that? This is so funny. Oh, Jesus Christ. Oh, this is so funny. I like it. This is perfect. It's average heading. Yeah, thank you. I don't even know what happened here. Maybe, what if... Okay, we can try to say that shied away Boyd is known because it's probably something related to separation rule. It feels like that. So let's just try to troubleshoot that. It's funny as hell. God damn it. Okay, great. It's probably not. Alignment heading. Get alignment average Boyd's heading. According to alignment rule. Okay, this is not the case. And cohesion rule. We get nearby Boids by cohesion distance. And we calculate the average position of them. Then we calculate from Boyd position to swarm position. And this is the cohesion heading. Then what do we try? We calculate the average heading between the cohesion and alignment. And then we take an alignment. I fail to understand what's going on, honestly. So there was another trick, interesting trick, to make the alignment more influencing, like to calculate the average of several of them. I don't even know where to start from, like seriously. This is so funny. Oh, I think I know what's the problem. Probably this is related to too quick turning. I don't know. I don't know where the problem is though. It's so weird. Maybe in the calculation of average heading, of average position. Something in that. Why do they like spin so fast? They're sort of twitchy. Okay. So the separation... Oh my god. The separation rule is not available anymore. Separation distance. Okay. So weird. It should work. I'm falling asleep, unfortunately. I don't know what's going on. I think I kind of know what's going on. It's because of the fucking mouse. That's right. This rule is not meant to work with the mouse. So that's why they are so twitchy. So instead of next boids, yeah, let's just remove the mouse thing. I'm gonna use just boids. This is interesting. So they shouldn't be twitchy anymore, hopefully. Okay. No, they still are. They separate so weird. Why do they separate like that? Ah, God damn it. Shy Boyd, Scary Boyd, and we just calculate a new heading. We don't have to... we modify the heading. God damn it, this is so stupid. I don't have to... I don't have to directly specify the heading. I just need to use guide function. Because I need to modify steer, not the heading. I'm so stupid. I'm really sorry, guys. I just wasted everyone's time already again. Okay, so what do we do? Guide Boyd to angle. I said angle. What is that? It takes an angle, unfortunately. Okay, so you take an angle. And we just apply it like that. Okay, here we go. So it compiles, and we have to do the same thing here. So maybe I don't even have to... Yeah, guide Boyd to angle, shy Boyd, heading, and not headings, heading. Why don't you work? Okay, this is because I have to swap them. That's right. So now it should be better. Excuse me. Okay, here we go. I'm ready. Come on, could you... Yes! I think it's better. Okay, they start to form flocks. Oh my gosh, they're so beautiful. They're too close to each other, I don't like that. So we want to make something like 220, I mean. 2/10. Instead of 20, I'm gonna say 2/10. I'm falling asleep. God damn it. That is interesting, actually. But it feels like there's not enough Boids, honestly. Random... Can you explain why maybe Boyd results in maybe... yes, it's a really good question. It does not. This expression is not maybe Boyd, honestly. The type of this expression, I believe... Can I look up the type? Asking for show type of... I'm not sure if I can. So, average heading takes the list of floats and returns maybe float, right? So when we lift A2, like the type of this expression is maybe float, right? So maybe float. What I do, I flat map it with ID, which essentially just floods it into just maybe float. So it's not a maybe Boid in the first place. So it's maybe float, maybe float, something like that. I don't know if I answered this your question, but I tried to. I'm really sorry. So yeah, the type of this thing is not maybe Boid. That's the point. It's maybe float, I think. Yeah, you're welcome. So I just flatten it, the entire type. Oh, okay. So I guess we're done on the combined rule, and right now I'm just tweaking the parameters. I'm not sure if it's better or not. It's very difficult to say. But they're wiggling. They're wiggling so adorable. You see how they wiggle? I like that. Oh my gosh, it's so adorable. They wiggle the same way that they wiggle in the JavaScript version. Why do they follow the same direction again? God damn it, I don't like that. I don't think it's somehow related to the bug. So it's probably because they do not affect each other and just happen to follow the same direction. So what I wanted to do, I want to make more boids. For example, instead of 100, I want 300s. 3 times more boids. I don't use terminal, use Emacs. This is really difficult stream today. I don't know why. I don't understand why is it so difficult for me. Wow. Why do they follow the same direction again? Is this just me, or they should not? Okay. Maybe something wrong with the calculating. So they not always follow the same direction, but when they form flocks, they sort of stabilize. Okay, maybe we can make the groups bigger. They also don't seem... No, they separate. I think they separate, but the separation radius is just small. Is 10 times smaller than the cohesion radius, I think. That's the reason. Wow. It's a little bit slow. It looks cool, but I don't think it works right. So let's make... Oh my god. Let's make the separation radius even smaller. Maybe I shouldn't do them small. I don't know what to tweak exactly to achieve the behavior I want. I'm not sure which exactly behavior I want. Like this time they go to different directions though. Oh yeah, this is interesting. So since the separation is smaller, they just kind of stick together. I'm still trying to... Wait a minute. Okay, maybe this is somehow related to the wrapping the angle. Okay, so what did I do already? So this one... Boids with... what the fuck am I doing? I still need to... What is... Let me just check the utilization of resources. Okay. Why did I exit the development environment? I'm tired. I need to finish the stream, but I cannot finish it that easily. So they are too close, in my opinion. Let's make it even more interesting. Let's make them faster. Oh my god. Yeah, I'm tired. I'm straight up tired and I cannot think, but I need to finish that. I want to make them look good and just, yeah, and just rest in peace. Finally. Did I screw up the alignment rule again? Adjust. I take, in the alignment heading, I take get nearby Boids by alignment distance. Right, and average Boids heading. Seems to be alright though. Okay, let's make the groups smaller, like that smaller, and separation is 20. I'm tweaking the parameters again. I don't think, I don't know if it will get us anywhere, but maybe. But there is a different problem in how I... They're trying to follow the same direction again. God damn it. Why? Why does this happen? And it's roughly the same again. It's roughly the same. It bothers me so much. I don't know. So there's probably something wrong with heading. I'm not sure. At some point. Maybe we have to wrap it as well. How do we wrap it? Fucking hell. Maybe by 2 pi or something. I mean, I don't remember having such problem before. Okay, so this is the entire change, right? What if we stash it and try to compile it again? So we're gonna use the previous algorithm for all of that. And the previous algorithm, I don't know which one is better, but they don't follow the same direction. Maybe they do. Maybe this is because of the amount of... They're still trying to. Why do they follow that direction? It's so weird. Oh my god. Okay, I remember that I did the following trick with the next boys. I'm not sure if it's gonna work or not. So I sort of converted that. I need to look it up. Gloss Haskell. So I need to convert it to point, maybe to unit point, and back to angle. I can do something like that, yeah. So I'm not sure how it's gonna help, but yeah, there's unit vector at angle. Revert. I don't know how it's gonna help, so yeah. We'll see. I don't even know what I'm doing anymore, so it's a really bad sign. So I'm just guessing the problem. It's really bad. So fucking annoying that they follow the same fucking direction, honestly. Okay, what if I make this separation and alignment big again, maybe even bigger than they were, Maybe the speed of the board. I don't know what I'm doing, honestly. Like, I don't know if it's a problem, if it's a bug in my code, or it's just it depends on the parameters or something. It's really difficult to understand. Oh, they follow the same direction because fuck it. But I like how they do that. Like, they look good. Probably. Another thing that we can do, we can narrow their vision a little bit so they don't get affected by the boards behind. Yeah, this is something about such algorithms. You cannot just program them. Why did they go there? This is so weird. They just go there. No matter what. Yeah, narrowing their vision wasn't a good idea though. So yeah. So at this point, I don't even know what the heck is going on. It's just, it didn't fix the bug with the same direction. Is this using a library or built-in? For what? You mean for graphics? If you're talking about graphics, it's a separate library. Yes. If you're talking about something else, no. For graphics, it's called Gloss. Haskell Gloss. Yes, this one. Yeah, this is for graphics. Okay, everything just died. Maybe I have to make less boards though. Maybe it's too much. Maybe this is how I generate them. Random Boid. It also has a random steer, but I don't know why should it have a random steer. Maybe it should have steer equal to 0. Let's try to do that. So steer, like initial steer is gonna be 0. Yeah, that's true. Oh, this is... And they attracted to that specific angle for some reason. I don't know why. I mean, corner. I confuse English words. I'm sorry. Angle, corner. Or maybe it's... No, it should be corner. So, I don't even know what I'm doing at this point. Steer velocity, steer delta time. What else I didn't check yet? The cohesion. Where is that? Okay, so the alignment. I need to adjust. Thanks for following userman too. I think I remember that nickname from somewhere. Oh yeah, from chat. Sorry. Okay. So maybe the alignment should be a little bit bigger, or maybe not. So cohesion heading. Where did they introduce an error again? Where is that? Okay. Just let's have a thing like C# linku the where make me think it does. How to answer that? I'm not familiar with linku, but from what I heard, you can assume that the entire Haskell is just a big, huge linku. So what? Yeah. So let's make it a little bit smaller. I'm just tweaking the parameters of the entire system, hoping to fix something, hoping to achieve the behavior I want. So the behavior I want, I don't want them to follow the same fucking direction, though. This is what I don't want, but they keep following that. Well. So spirit is a big. And they're so attracted to the corner, the left upper corner. It's like, why? Why do they all attracted to that? Are they attracted? Okay. And it's like, they move all by the diagonal. Fucking, oh my gosh. Okay, I don't know what's going on, seriously. Don't like that. It shouldn't happen. 100%. This is weird. I fucking understand. Yeah. This is not that should happen. Like, it's a really wrong behavior, and I don't understand what causes that. So it's maybe it's Boid or shied away Boid or interested Boid. So try to go from scary. It shouldn't be like that. We shy away from too close Boid to close Boid. So maybe I don't. Alignment head. When we align, we take all of the Boids inside of alignment distance and we take the average heading of them. And we use that heading as an alignment heading. Regarding the cohesion heading, we take all of the nearby Boids inside of the cohesion distance and we take the average position of them. Right. So once we have the average position, we try to move from the Boid position to the swarm position, and we take the angle of that thing. Right, and then what do we do? Once we have average heading and alignment heading, we try to combine them. We calculate the average heading of cohesion and alignment, and if somebody is missing, we either choose the alignment heading or the cohesion heading. So we can, maybe that's the case. We can try to swap them. I don't know how that can affect, but this shouldn't affect at all, so it's really strange. No, it does nothing, honestly. Maybe this is how we guide them. Guide Boid to angle. And this is interesting. So this is kind of an error margin. Oh, it's really interesting. Maybe it's too many. Let's make them a little bit less. Like I wasted so much time and I didn't finish the task again. So I cannot commit it and call it a day because it's not finished yet. And I don't know how to finish because I have a problem. I faced a problem that I cannot quickly fix. They shouldn't follow the same direction. I already fixed that. Okay, let me just see what changes I made. Maybe it will help me to understand. And I cannot fix that because I'm already fucking tired. I'm just fading away. Like, oh my god. Oh, this is so terrible. Oh, I wanna sleep, but I cannot finish the stream until I get it done because I will lose the context and all of this like hard work will be for nothing if I finish right now, because I'll forget everything and I'll have to start from the scratch. This shouldn't happen. Like, that must not happen. I must finish that right now. If I don't finish that, like, what's the point of the stream? Like, the stream was completely pointless if I just won't fix that right now. And, where's my tea? I'm falling asleep, seriously. So this is not because of this steer. Something in the combine rule. We can probably easily check if it's caused by... I don't know what it's... It's really difficult. Okay, so the following thing. If we make the groups really small, they're already pretty small though, but let's make them even smaller. And separation small as well. Why do I use terminal? Let's just do that from Emacs. Come on, you can do that. Should work. Okay, the groups are really small. When they form groups. Okay, this is interesting. When they are alone, they move whatever direction they want. Once they form some kind of group, they start to follow the same direction. I think that's the root cause. Somewhere there. Okay, this is interesting. So we might be actually try to bisect that. So it's either in alignment or in cohesion. So we can turn them off. We can try to turn off some specific things. For example, I can disable the cohesion. No. Excuse me. Just nothing. Go. Cohesion. Bum, bum, bum. Okay. When they form group, some groups move to other direction, not in the same. I think we found the root cause, kind of. Did we? Yeah. Well, like for example, these groups specifically, it's a group, but it's moving down. Yeah. It's in cohesion, so cohesion fucked up the entire situation. How did that happen? I wonder. So I need to read that code a little bit closer. So we get all of the nearby Boids by the cohesion distance. And we calculate their average position. How their average position looks like. Well, looks okay. This is how you calculate the average position, though. So maybe, yeah, something like that. And also from Boid to swarm position. So maybe we have to make the influence of cohesion less, way more less, and more like alignment. Okay, something went wrong. Oh, because they have to. Okay. Let's try that. I don't know if it's gonna help or not, but the entire cohesion rule seems to me really strange. Okay, the cohesion rule kicks in and maybe there is some kind of overflow somewhere. Okay, some groups try to move to other direction, but generally, for some reason, god damn it, I lose everything. Okay, this is just small groups. Let's make them back big again. Like that, 20. Okay, let's take a look how they are going to behave now. Come on. God damn it. Just why? Okay, I'm gonna make them faster. I don't know why. Okay, made them faster. Maybe I have to make them rotate slower. Well, this is interesting. Haskell is even lazier than most people think. In mainstream languages, when we talk about laziness, we usually talk about lazy collections or lazy whatever, yeah, lists and stuff. But in Haskell, everything is lazy. Like everything. You won't believe how lazy it is. There's a classical example of that, which is really interesting. I don't know how to show that. So, for example, we can have a function that calls itself, right? And it's obviously infinite program, so it will never stop. We can try to run it, and will never stop. We can only interrupt it, so it will always go forever, right? And we can create another function, g, that takes 2 arguments and returns the second one. Then, I'm not sure if it's gonna compile or not. We can invoke, for example, f with 5. It's probably not gonna compile. It returns f and it returns 4, but instead it should have been hung up. So essentially, it just didn't calculate f because it was never used inside of g. So this is how lazy it is. It's not only about like collections and stuff, like everything is lazy in Haskell. You always have to keep that in mind. And if you're not used to such order of computation, you won't be able to efficiently predict the complexity of your algorithm and stuff. So yeah, it's kind of interesting. I don't fucking know what's going on, honestly. Yeah, it's probably interesting. I can even show them these ones. Do they look like visual thingies? I think they do, but they don't do exactly what I want them. So they seem to attract the same direction, but they should actually follow different directions as well. So they should form flocks and move to different direction, but for some reason they just follow the same. Yeah, I don't know why. I'm trying to troubleshoot that. And I cannot. And I'm already tired. Yeah, they also swarming. Yeah, it's Boids. It's a really simple swarming algorithm. So I provided the page somewhere in the YouTube chat, so I can copy paste that again. So if you're interested, so here's the sort of an official page about Boids algorithm. I'm working on that simple algorithm for 14 streams, and I still cannot get it right. Maybe this is because you have to constantly tweak the different parameters, the initial parameters of the system, and it's quite difficult to get it right. And I'm not sure, like, they follow the same direction, and I don't know if that's a bug of the implementation or just the wrong initial parameters. It's really hard to tell. Like, I don't know. Like, sometimes they follow different directions, but sometimes... I don't know. It's really suspicious that all of the swarms, like, decided to go the same direction. It's really weird. It shouldn't happen. It feels like I use the alignment heading for all of the boys again. Maybe I don't... What's the alignment distance? I don't know. So, and it's definitely something with cohesion. We already found that. Get nearby boids. Cohesion heading. First one is cohesion. Okay. Nearby boids, cohesion, average boid was... I don't know. I didn't see anything. Okay. Is this a neighborhood not too large? Obviously question with no knowledge, but... The neighborhood not too large. I don't even know what do you mean by neighborhood though. So you mean the size of the group of the swarm or something? Maybe it has to be a little bit bigger. Where you had that by 2 code, perhaps with computing the center was not the integer division. Oh, wait. I don't know what you mean. Wait a second. Like the integer division might be a clue. I also swear I'm seeing more and more Emacs, and I mean like the distance at which they are noticing it. Yeah. Okay, so we were talking about like the same thing. You're seeing more and more Emacs, so you think Emacs becomes more and more popular? I believe Emacs is the least popular editor. Like among Vim, Atom, and Sublime and stuff like that, is the least popular. And it's actually pretty good that it becomes more popular recently. Okay, so maybe average heading from integral. I'm not sure if you can easily get so the Haskell is statically typed, so it probably won't happen that easily. Maybe average Boid position. For positions we use what? It's a point, and point is a tuple of floats. Pretty sure. Tuple of floats. I think it might be more popular with those doing more serious topics such as compilers, OS, and maybe. I mean, yeah, it's really popular among the academic people, and they usually do the compilers, operating systems, and artificial intelligence and stuff. But I'm not an academic person, I would say. I mean, I probably want to be a teacher at university, but I'm not sure if any of the universities will hire me for that role. So still trying to. I'm falling asleep, unfortunately, and probably, but it's really outdated. The algorithm itself is really old. Nobody except me is really interested in that algorithm anymore. They use it I believe it was invented in Disney, so they use it for some computer graphics movies, I guess, for just generating good-looking flocks of stuff. But now there are more advanced algorithms. The advantage of this algorithm is just it's really simple. You can really easily implement it if you're not me. Okay. No. Something wrong with the cohesion. So we start from swarm to Boids. Okay, so let's try to do that. I don't remember if I tried the opposite direction though. It's kind of stupid, but let's just give it a try. Yeah, they start to separate from each other. It's so funny when you don't have a cohesion rule or just an opposite of the cohesion rule. But still, they go somewhere up, and I'm pretty sure I can reproduce that. And they will go up somewhere. So yeah, they go up again. Kind of. They should do the opposite thing. Maybe I have to trace that, honestly. Can I trace the cohesion somehow? Let's try to trace that. It's really difficult to trace though. Also probably have to provide some I don't fucking understand what you want from me, but it's really difficult. Oh my god, how do I fucking trace that? Okay, you want overloaded strings, okay. It's such a big such a big expression, and I cannot easily trace that. And Emacs has a weird syntax. Okay, from void to swarm position. I'm so fucking tired. I want to already finish that, but I cannot, because if I finish right now, the entire stream will be for nothing, honestly, because I will have to start from scratch. God damn, it's so fucking... Okay, I want to quickly do one thing. How is heading defined in Radiance? Yeah, yes, in Radiance. I want to make a quick break for a couple of minutes, and then we're gonna continue. So yeah, have fun. Alright, I'm back. How everyone's doing. I don't know what's going on, so I'm gonna do last try. So we have heading, because I'm still... it's probably something related to heading. I'm gonna use next heading, because I remember that I wrote something like wrap heading as well. And in the original implementation there was some weird wrap of that thing, which is more like that. No, why? If it's supposed to wrap it somehow. I'm not sure if it will help. You know, it kinda helped. Wow, this is mesmerizing. Honestly. Wow. This is cool. Why did that help though? We need more of them. 300. Even though it's too much for the current really inefficient implementation, but I just want to see that. Yay. Yay indeed. Okay, get ready for the lag. Oh my gosh, you can do that. Oh my god. Wow. Did it fix that? I think it fixed that. Sort of. Wow. It lags a little bit, probably because of the garbage collection or some kind. I like that. It looks so fucking cool. And I think it's better than the previous implementation. Okay, I want to tweak some parameters. I'm not sure if I need to, but we can try to just reduce the size of this worm. Where is my everything? God damn it. One more time. I think I finally did that. So we reduce the size of the group, so the groups are smaller. Wow, I so fucking love it. So it looks cool. Like sometimes they divide, sometimes they merge. Okay, let's take a look at the previous implementation and see which one is better. Okay, the previous implementation looked like that. Just need to wait a little bit. Maybe we need more. The previous implementation had less Boids though, so let's just modify it a little bit to get more of them, like 300. It will be cool if they introduce linear types and eliminate the need for garbage collection. Probably. The new one is a bit more active. Yeah, probably. Maybe this is because it's faster. Oh my gosh, stop. Oh, it's so laggy. Is it laggy? Like, does it affect the stream? It's impossible. Yeah, the new one is probably more efficient. Yeah, because it's just one function instead of 3. Probably that's more efficient. They also try to follow the cursor. I think the new one just looks a little bit interesting because they are not static. They try to, you know, interact with each other or something. But these ones, they also follow the same direction again. God damn it. But in this implementation, we can attract them with the mouse, which is kind of cool. Yeah, I need to do that. I like how yeah, it's kind of funny. So I think the new one is better. So let's just apply the new one again. See how it's look like. Yeah, and the new one can handle 300 Boids, which is cool. Yeah, I like the new one better. Like, it's so like alive, I would say. You can feel that they are sort of alive. So awesome. Like that. I can watch that all day. This is so fucking cool. Okay, so I think I want to finally commit that because it's a pretty good work. Implement combined role. 64. Finally. I'm probably gonna tweak that a little bit, but that's already off screen because I'm not sure if tweaking is actually interesting to watch, but maybe it is. Who knows? I want to watch the Boids a little bit more. Yeah, probably. But I think I need to improve the performance. Like right now, the implementation is really naive. It's really linear. I would like to use some, I don't know, fancy data structures. But since it's a functional programming language, I probably need to use even fancier data structures. Because, yeah. I can't have any mutable data structures though, so I have to come up with immutable ones. So I was just thinking how to improve the proximity search, probably. Just when I have Boid, I need to calculate the nearby Boids, so it's probably some kind of a, I don't know, space tree. I'm thinking about KD tree, but I think it's probably a pain in the ass to update it all the time because it's such a dynamic system. It's probably going to be pain in the ass for like updating any kind of data structure with such a dynamic system. But yeah, so I need to research that. Alright, I guess that's it for today. Finally. Thanks everyone who's watching right now. Really appreciate that. Have a good one and I see you on the next stream. The next stream is gonna be about something. Let's take a look at the schedule. Yeah, the next stream is gonna be about Developer. It's just digital music clipper in Rust. So yeah, I see you on Wednesday. Thank you guys. Bye bye. Bye bye.